No, it worked. Y'all did it. Okay. All right. So now we are. Oh, the barking? It just adds volume, right? Kind of like when you add wheat germ to hamburger meat to make it spread further. What? Okay, you didn't grow up poor. All right. What? Wheat germ. Wheat germ. Germ of wheat. Oh, wheat jam. I've never had that. Sounds pretty delicious, actually. All right. Like breadcrumbs. You put breadcrumbs in the hamburger meat to make it last longer. Okay? Ooh. What? You're putting it on bread anyway if you're having hamburgers. What? You never had a hamburger with bread? Oh, okay. Well, it's kind of like putting bread in the hamburger meat. So it's like a hamburger. It's like Inception hamburger. All right. So here we go. Example 9. We're going to run through. These are like common angles from the unit circle that everybody's memorized. And remember that even if we're not on the unit circle, where the radius is 1, these ratios will work because your scale factor divides out. So it says using the unit circle and those identities, go ahead and find all 6 trig functions for the following angles. So we're going to list all 6. Any one of these 6 could appear on your quiz on Monday. So let's just go ahead and set it up first. We want sine of 5/4, and we want cosine of 5/4. I typically list sine first, but maybe I should get in the habit of doing the other way around, right? Because cosine is x and sine is y. Very good. Sine y. So we got tangent of pi, 5/4. And then let's go ahead and do like we've been doing. The reciprocal of cosine, the reciprocal of sine, and the reciprocal of tangent. Okay. So any one of these 6 could appear on your quiz on Monday, right? And you're going to have on Monday, again, a minute per problem. But here's what I would recommend, okay? And it doesn't take long because even after all these years, I still don't flat out have the unit circle memorized, but I can assemble things very quickly. So when you read cosine, sine, tangent, anything of 5/4, here's what you should pick up on first. Fourth, 5/4, okay? And so anytime you hear 5/4, you should be thinking of this ordered pair, right? That's your 45-degree reference angle. Square root of 2 halves, square root of 2 halves. Good. Now, look at the ratio. It's 5/4. 5/4 is just a smidgen bigger than what? 1. So it's a smidgen bigger than 1 pi. So that's going to put you in quadrant what? 3. Good. And now, to get to quadrant 3 from the origin, okay, we have to go left and down. So that should be negative, negative. All right? So now that we have the ordered pair either visualized in our head or written down. You could write them down. On Monday, you will have time to write down the ordered pair. And if you need to physically write it down to help you get it right, do that to begin with, okay? So now the cosine is pretty easy. It's just the x value. And, of course, the sine value is even easier because it's just a y value, everyone's favorite, one to hate. Hey, even if you're the favorite one to hate, you're still a favorite, right? Yeah, like lots of tape because it's broken like 4 times. But it still works like a champ, right? Why spend $5 for a new one, right? You can spend that $5 on chicken minis. Yeah. Now, tangent. Okay, here's where it starts getting different. Tangent is y over x, right? Tangent is y over x. So, for tangent and cotangent, you're always going to be dividing one of those ordered pairs by the other, or one of those coordinates by the other. Because we worked hard to get the denominators to be the same all the way around, 2's, they're always going to divide out. So if you're ever doing a tangent or a cotangent, you don't even need to worry about the denominators at all. Just forget about them, okay? And so now it's just going to be the y value with the sign, so it's the numerator, over the x value with the sign. You got to take the sign. So what is the negative square root of 2, bless you, divided by the negative square root of 2, bless you? Yeah, anything divided by itself is 1. So that's going to be 1. Well, because they're going to divide out. If you want to see it in slow motion, yeah, we don't just like take gimmicks in here, right? But once we see why something works, then we can generalize. So if I do state change flip, that's going to be times 2 over negative square root of 2. Those 2's will always divide out, always. Okay, always. And so you're just left with the numerator of the y coordinate divided by the numerator of the x coordinate, which in this case they're also the same, so they also divide out. All right, so now that we have that, let's just jump over here. What would cotangent be? Would it be any different in this case? No, your denominators, 2's are going to divide out, but now you just have the x numerator divided by the y numerator, and they happen to be the same, so it's also 1. So another thing that you can kind of remember is that anytime you have tangent or cotangent of pi fourths, tangent or cotangent of pi fourths, it's always going to be either 1 or possibly, if they're opposite signs, negative 1, right? Yeah. Tangent or cotangent of any pi fourths angle is always going to be 1 or negative 1. All right. Cool. So how do we get to the other two, the secant, cosecant? Well, those are almost easier because you don't have to divide one by the other. You just flip it, right? Secant is the reciprocal of cosine. So if you flip negative square root of 2 over 2, you get negative 2 over the square root of 2. But I don't want that as a final answer because it has a radical in the denominator. So we'll rationalize it by multiplying by radical over the radical. And if you multiply straight across, you get negative 2 square root of 2 all over 2. And what's going to happen every time with those 2's? They'll divide out. Okay? So I think we practiced this on the first day. The reciprocal of the square root of 2 over 2 is just the square root of 2, right? The reciprocal of the square root of 2 over 2 is just the square root of 2. Because if you remember, square root of 2 over 2 was after we rationalized 1 over the square root of 2. And so if you flip 1 over the square root of 2, you get square root of 2. Okay, and then what is the cosecant? Well, it's the reciprocal of the y value. And in this case, what is it going to be? The same. It's negative square root of 2. All right? So there you go for your pi fourths angle. Those are probably the easier ones. Your pi fourths reference angle is probably the easier ones. Tangent or cotangent, it's always going to be 1 or negative 1. All right. Any questions on that? Letter B. Yeah. Why is Berkeley here? Because she's tired of swimming every day. She wanted to start her day with math for once instead of chlorine. Yes.
So whenever you say there's going to be 10 questions on this, do you mean
like this would be 6 questions.
Okay.
Yeah, that would be 6.
I thought you meant that was like a 1.
No, that'd be 6 questions, right? Yeah, no, that's not just 1. That's 6 questions, right? It could be like numbers 1, 2, 3. I mean, I'll put them in random order for sure. 5, and then 6, right? Yeah. All right, good. All right, any other questions? Leave Berkeley alone. She's here on invitation. All right, 11 pi 6. So here we go. Whenever you, first let's get it set up. No, let's not get it set up. Let's think about blah, 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 pi 6. Anytime you have a pi 6 reference angle, it doesn't matter if it's 1 pi 6, 5 pi 6, 7 pi 6, or 11 pi 6, or 5,677 pi 6. It doesn't matter. If you hear blah, 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 pi 6 and it's a simplified ratio, it's always going to be some type of square root of 3 has 1/2. Always. So all you got to do is figure out what quadrant it lives in. 11 should jump out at you like, wow, that's quadrant what? 4, yeah. And because it's 1 less than twice the denominator. Quadrant 4, to get there, right, from the origin, to get to quadrant 4, you go right and down. So it should be positive, negatory, right? Now, once you're staring at the actual ordered pair, it's pretty easy to answer all 6. Let's do them in random order this time, okay? How about tangent of 11 pi 6? What do you think it's going to be? Tangent is y over x. Remember, for tangent or cotangent, you don't got to worry about the denominators because they're going to divide out. So it's just y over x. The numerator of y with the sign over the numerator of x, y over x. Yeah, because it's going to be negative 1 over the square root of 3, right? And you have time to write that down on Monday. You got a whole minute, right? And then when you rationalize, which eventually you'll do in your head, that's negative square root of 3 over 3. Perfect. That's tangent. All right, number 2, let's do cosine of 11 pi 6. I could throw some sine and cosines in there on Monday, sure. What's the cosine? It's just the x-coordinate square root of 3 has. Too easy. Too easy. Too easy. All right, let's get the other easy one out of the way. What's 11 sine of 11 pi 6? Negative 1/2. Okay. So now the fun ones again. Okay, how about secant? Call this number 4. Secant of 11 pi 6. Secant is the reciprocal of which one? Cosine, right? Secant, cosine. In fact, when you say secant backwards, it sounds like cosine, doesn't it? Cosine, dude, right? I just realized that. I've been teaching this 20 years. I just thought, hey, some people think reciprocal might mean backwards. So if you read secant backwards, it's cosine. If that helps you remember it, take that for free, okay? So if I flip the x-coordinate, I get positive 2 over the square root of 3, which when we rationalize it by multiplying by root 3 over root 3, we get 2 square root of 3 over 3, and that should be your final answer. You're going to get so good at flipping it and rationalizing in your head, you're going to be like, secant, flip, square root of 3, 2 square root of 3 thirds, boom, done. And now you're like, what do I do with all this extra time? I don't know. Well, I still have that thing stuck in my teeth from last night. I guess I was just trying to get it out with my tongue. All right. Oh, ew. All right. That's what floss is for. All right. Do that the night of, right? Right. Good oral hygiene. And make your bed every morning, right? Ugh. It's good enough to get out of. It's good enough to get into, right? Does not say my wife. We have to make it every morning, right? Okay. I know. Something about order and discipline and it feeling fresh. When you fold it and then you have to the sheets are tight and it's like I'm getting into a nice, clean bed. But we can't all be like Oprah Winfrey and have somebody clean and wash and change our sheets every single day. She has new sheets on her bed every single day. Yeah, But we're not Oprah Winfrey. All right. How about cotangent? Cotangent of 11 pi 6. All right. Cotangent. We don't have to worry about the denominators. No. So forget about you twos. It's x over y. So it's square root of 3 over negative 1. Square root of 3 over negative 1. Square root of 3 over negative 1. Right, which is just negative square root of 3. Booyah. Yep, sorry, it's boring. I know, right? So easy. All right. And what's the last one? What's the one that we're missing? Cosecant. Sweet. Cosecant of 11 pi 6. We're going to flip which one of these? The sine, right? Sine. So negative 1 over 2 flipped is negative 2 over 1, which is just negative 2. Yeah, listo, fertig. Done. All right, so any one of those 6 could show up on Monday's quiz, any one of them. And, of course, if it were like 7 pi 6, that would be quadrant 3. They would both be negative, right? So that shouldn't be the obstacle, getting into the right quadrant. In quadrant 1, the numerators are all 1 pi. In quadrant 2, they're always 1 less than the denominator. In quadrant 3, they're always 1 greater than the denominator. And then in quadrant 4, they're always 1 less than twice the denominator. So hopefully you're picking up on that pattern, all right? Well, I might throw some quadrantal angles in there as well. Yeah. All right, let's change 3 pi fourths because we've already done a pi fourths reference angle. Let's do audience participation. Y'all are an audience. Y'all are an interactive group. Y'all are pupils. What is y'all's favorite pi thirds angle? I know, right? 4 from which to choose. Yeah, which one? We haven't done, let's do quadrant 2. How about 2 pi thirds? I'm going to force that one on y'all. All right, there you go. 2 pi thirds, okay? So when you read pi thirds, regardless of what trig function's in front, you should be thinking 1/2 square root of 3/2, right? You got to get that memorized because what the tendency is for students is to get the pi 6 and the pi thirds backwards, right? Because it's the same values, it's just in a different order. So pi thirds starts with 1/2. Okay? Pi 6 starts with square root of 3 halves. Got to get that down. Commit it to brute force memory if you have to, right? Tattoo it on the back of your eyeballs somehow, right? Yeah, you go into a tattoo parlor and say, hey, I've got a task for you, all right? Take your parents with you, by the way, because you're going to need their permission. All right, now, 2 pi thirds is in which quadrant? Second, because 2/3 is just less than 1. So in quadrant 2, from the origin, I go left and up, left and up, left and up. That's negative, positive, right? And so you have time to write that ordered pair down on Monday. Now, let's do them in random order. How about cosecant of 2 pi thirds? What is cosecant? I'm asking you. That the reciprocal of sine? Cosecant is the reciprocal of sine? 2 over the square root of 3, which then becomes 2 square root of 3 over 3. Good. And you're going to get so great at it, you're not even going to have to write down 2 over the square root of 3 eventually. Okay, good. How about cotangent of 2 pi thirds? Cotangent, tangent, forget about the denominators. What sign, though? It's x over y, forget about the 2. So it's negative 1 over the square root of 3, which when we rationalize is negative square root of 3 over 3. There you go. Don't get so focused on trying to rationalize that you drop the sign. Okay? A negative over a positive is a negative. And I don't care if you put the negative in the top, bottom, or out in front. It doesn't really matter. Let's do all the co's first. So what's the last co we have? Cosine. So cosine of 2 pi thirds, negative 1/2. It's just the x-coordinate. Kind of boring. Yeah. It's amazing I didn't fall asleep during that quiz we had on Wednesday, right? Snooze fest, right? Using the unit circle number 1. My gosh. Okay, how about we've already done co. Sorry, my bad. Secant. Secant of 2 pi thirds. Secant backwards is cosine, dude. Negative 2. It's the reciprocal of the x-coordinate. The x-coordinate is negative 1/2. You flip it to get negative 2 over 1, which is negative 2. Okay. How about tangent? Tangent of 2 pi thirds. It's y over x. Forget about the 2's in the denominator. Negative square root of 3. Good. Because it's square root of 3 over negative 1, which is negative square root of 3. That's why we worked hard to get all the denominators to be 2's. Okay? And then the last one, I guess, is sine. The best for last, as I say, right? Sine, y, square root of 3 over 2. So any one of those 6 could be on the quiz, right? And, of course, any pi thirds angle could be there, too. All right? So you can have either regular pi thirds, which I think is kind of boring because they're both positive. You have 2 pi thirds. You have 4 pi thirds, which would be quadrant 3, where they're both negative, or 5 pi thirds, where it's positive negative. All right, and then the last type of question I could ask is a quadrantal angle, like 3 pi halves. All right? So these are kind of fun, maybe a little bit easier. So now you're like 3 pi halves, why? That's not on the interior at all, right? So you just have to remember 0, pi halves, pi, 3 pi halves, 2 pi, right? So 3 pi halves is way down here. What's the ordered pair? 0, negative 1. Not negative 1, 0. 0, negative 1. Don't go left or right, go down 1. Boom. You're staring at your x and y, so you got them all. So what would cosecant of 3 pi halves be? Cosecant is the reciprocal of sine. If you say cosecant backwards, it's still cosecant. That doesn't help you. But you should know it's the reciprocal of sine. What's the reciprocal of negative 1? Negative 1, yeah. 1 and negative 1 are their own reciprocals. Negative 1 and 1 are their own reciprocals. Okay, bless you, what's cosine of 3 pi halves? 0. Very, very good. What is secant of 3 pi halves? What's the reciprocal of 0? DNE, because it's some type of infinity. Because when you say 0, when you flip it, you don't really just flip the number, right? Because 0, when you flip 0, looks like 0. It's really 0 over 1 or 0 over 5, whatever. When you flip that fraction, you get 1 over 0, and now it's like, wah, 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 wah. You can't divide by 0. Non-zero over 0, remember, means the graph has a vertical asymptote, which means the y values go to either what? Infinity or negative infinity. So what's the reciprocal of 0? DNE, because it's infinity. What's the reciprocal of infinity? 0, right? Try it again. What's the reciprocal of 0? DNE, because it's plus or minus infinity. That's why we don't say infinity, because it could be negative infinity. We just say DNE. But what's the reciprocal of infinity? 0. Okay, good. So we'll say DNE. The reciprocal of 0 is DNE. Okay, how about tangent of 3 pi halves? It's y over x. Yeah, it's negative 1 over 0. Wah, 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 wah. Can't divide by 0. Now notice that secant is r over x. Tangent is y over x. Those are the only two trig functions with x in the denominator. And so when x is 0 on the y-axis, they're both DNE. But you can understand that, or you could just go with the ordered pair. All right, what would sine of 3 pi halves be? Negative 1. That's easy. Okay, so what are we left with here? Cotangent of 3 pi halves? That's x over y. X over y. Yes. 0 in the top alone is 0. 0 divided by anything except 0 is 0. 0 divided by 5 is 0. 0 divided by 10 is 0. 0 divided by 100 is 0. 0 divided by 0 is undefined. Okay. So is that all 6? Yeah, that's all 6. So there you go. And you'll see that for any quadrantal angle, 0 pi halves, pi, 3 pi halves, 2 pi, you're going to have 2 of them being DNE every single time. 2 of them will be 0, 2 of them will be DNE. And the other 2 will be 1 or negative 1. There you go. We just ran through all 6 trig functions for each one representative of each of the types of angles you'll see. So now you just get to generalize it. One last theorem here real quickly, because I kind of just skipped the last of this. Coterminal angles have the same trig ratios. Coterminal angles have the same trig ratios. So, for instance, if I look up here at, let's do pi thirds. Okay, what's the ordered pair at pi thirds? That's right, 1/2 square root of 3/2. Good. What if I went around another full rotation? What if I went around another 2 pi? What's pi thirds plus 2 pi? Well, that's the same as pi thirds plus 6 pi thirds, right? That gives us 7 pi thirds. So 7 pi thirds is coterminal with pi thirds. So if 7 pi thirds goes around once and then goes to that terminal ray, guess what the ordered pair is for 7 pi thirds? Because it lands at the exact same spot, it's the same ordered pair. And because it's the same terminal ray, it's the same ordered pair. Because it's the same ordered pair, it's the exact same trig ratios. So any coterminal angle will have the exact same trig ratios as all of its infinitely many other coterminal angle buddies. Okay? So that's just kind of a nice little thing. All right. So there you go. So what are you going to be tasked with now for the rest of the period, which is like 20 minutes? I want you to go to Corpy's World, na 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 na, Corpy's World, and then come down here to using the unit circle practice, 5.3b. Some of you all have already done this. That's fantastic. Using the unit circle practice. Try to time yourself if you want to have that extra layer of zest. But if not, just try to get through all 10, because these are like sample quizzes. Because starting on Monday, we're going to quiz every single day. And the time is going to get shorter and shorter. All right, so we're going to start with 10, then we're going to go to 8, then we're going to go to 6, then we're going to go to 5, and then we're going to go to 4, and then we're going to go to 3. And 3 is the fastest that we're going to make you do it. But then we're going to have a ghost pepper challenge, like at the end here. Supposedly ghost pepper is the hottest chili pepper out there, but they're engineering these things all the time, so maybe there's one that's hotter than the ghost pepper. But I'm going to give you all a chance to do them in 1 minute. And if you score a perfect score on that 1 minute ghost pepper challenge, you'll get bonus points on your test, okay? So it's an optional thing. And then at the end of this, it says, congratulations, take a drink of water. You're now ready for tomorrow's quiz. I drew a glass with some ice cubes in there and a straw, but it's not showing up. That's a bummer. Anyway, here's what I want you to do for the time that remains. The very first one, I put 6 minutes on there. We've already done it in 10. That's just the generic one that you've already taken with sine and cosine. So starting with set number 2, those are like what you're going to see on Monday, okay? Just a random assembly of the 6 trig functions combined with just all the angles. So go ahead, if you want to time yourself, do that. Maybe take one test, and then I have the key back here that you're welcome to come back and look at if you want to take a photograph of it or a picture of it, whatever you call them these days, an image, a selfie with the answer key. And then see if you got them right, okay? And then do them in 5, try to do them in 4. So if you press yourself to try to do them in a faster amount of time, over-preparing is better. So there you go. You can do them directly on your iPad. I'm not going to make you turn this in, but I think it would be worth your while. So I have 3 copies of the key, which I will leave laying on this back counter for you to arise from your desk and check. If you take a picture, that kind of defeats the purpose for in class, but I know if you don't finish them and you want to have the answers over the weekend, maybe take a picture at the end of class. But try to come up and just verify that you got them right. And if you come look over here, the little, if you want to just see my artwork, because I took Art 1 here back in 1988. Yeah. And so my art skills are a product of NBHS. I drew a little glass, and you can see it on the key here. So anyway, that's it for the rest of the period. Any questions? Practice, and then what's the third one? Practice. Okay, good. That's it. The rest of the time is yours.